In this video, we're going to wrap up our discussion of compound events when we talk about independent and dependent events. So what are independent and dependent events, and how are probabilities of independent and dependent events calculated? So what we're going to talk about is whether two events or two or more events in a compound event have an effect on each other. So let's go back to the coin flip and the spinner example that we've used several times already and ask the question, does the outcome of the coin flip affect what you will spin on the spinner? So if I flip tails on the coin, does that make any one of the colors on the spinner more or less likely to happen? And the answer to that is no. The outcome of the coin has no effect on the outcome of the spinner. And then likewise with the dice roll, we roll two dice. Does the outcome of the first number cube affect what you will roll on the second number cube? And the answer to that as well is no. If I roll a 2 on one of the dice, that doesn't make me more likely to roll a 2 or less likely to roll a 2 on the second dice. So we call these events independent events because they're independent of each other. If you are independent of something, that means you don't rely on or you're not affected by something else. You are independent, you're your own thing. So two events that have no effect on the outcomes of each other are called independent events. And then likewise, here's a scenario. Does taking a marble out of this bag affect the outcome of the next marble that I take out? So let's say, for example, I take this yellow marble out of the bag. Does that change my probability of grabbing another yellow marble out of the bag? Well, absolutely it does, because once the yellow marble is taken out, there are no more yellow marbles, so that changes the outcome of the next marble that I grab out. So we would say yes, whatever I grab out of the bag affects what I will grab next. And then likewise, if I have a deck of cards, does taking a card out of the deck affect the outcome of the next card I take? And the answer to that again is yes, because there's less cards in the deck now, and the card I took out is no longer in there, so I can't pick it again. So we call these events dependent events because the second event depends on what happens in the first event. So two events where the first event affects the outcome of the second event are called dependent events. And these probabilities are going to be calculated differently. So here are the two ways that we're going to calculate these probabilities. So if A and B are independent events, if they're independent of each other, like the coin and the spinner or the two dice, we're going to calculate the probability as follows. So if we have these two events, A and B, we're going to find the probability of A happening and then multiply it by the probability of B happening. And then that's going to be the probability of both of them happening together. And then that is different than dependent events. So if A and B are dependent events, like the marble bag and the card draw, the probability of A and B is the probability of A happening times the probability of B happening after A occurs. So now we have to readjust and assume that A has happened, and now figure out the probability of B happening after A has occurred. Now we're going to look at some examples of these. So whenever we're dealing with a compound event, we first have to ask ourselves, is it independent or dependent? Because they're calculated two different ways. So let's look at this scenario. One letter tile is selected and the spinner is spun. What is the probability that both outcomes will be a vowel? Well, these two events have no effect on each other. Whichever tile I grab here has no effect on what I spin on the spinner. So these are independent events. So if they're independent events, we're going to jump back here and look at that. If they're independent events, I'm going to find the probability of the first event and multiply it by the probability of the second event. So to find the probability of both vowels, I'm going to find the probability of the tile being a vowel and multiply that by the probability of the spinner being a vowel as well. So if I look just at the tiles, there are 4 tiles, so there's 4 possible outcomes. And E and A are the 2 vowels. So there are 2 out of the 4 are vowels. So the probability of getting a tile vowel is 2 out of 4. And the probability of getting a spinner vowel is only 1 out of 3. So I multiply these probabilities together. 2/4 times 1/3 is 1/6. or 16 2/3%. And there is my probability. The probability of getting a vowel on both of these is 1/6 or 16 2/3%. So these were independent events. Here we have 4 oranges, 7 bananas, and 5 apples in a fruit basket. So there are 16 total pieces of fruit in the basket if you add all those together. You take out a random piece of fruit, and then your friend takes a random piece of fruit out. What is the probability that you both grab an apple? So if I take a piece of fruit out, is that going to change the options for my friend? And the answer is yes. This is going to change the outcome depending on what fruit I grab. So these are dependent events. The 2 fruits that we grab are dependent events because the fruit my friend grabs depends on what fruit I grab first. So what's the probability that we both get an apple? So we're going to find the probability of me grabbing an apple and multiply that by my friend grabbing another apple after I grab an apple. So that's how it's different from independent events. So the probability of getting an apple is 5 out of 16. Okay, there are 5 apples out of 16 pieces of fruit. So my probability is 5/16. Now I'm going to multiply that by the probability that my friend now gets an apple. Now here's where dependent events are different. Now we got to ask ourselves, how many pieces of fruit are still in the basket after I take one out? There are only 15 pieces of fruit left in the basket. So now my total outcomes are 15. And now I ask myself, how many apples are left in the basket after I take one out? There were 5, now there are 4. So now the probability of getting an apple after I take one out is 4 out of 15 instead of 5 out of 16. Do you see the difference there? So now all I have to do is multiply these probabilities together. 5/16 times 4/15 is 1/12, or that's about an 8 1/3% chance that we're both going to grab an apple. So again, dependent events, that second probability is going to change after the first event happens. So now let's look at the probability of me grabbing an orange followed by my friend grabbing an apple. So I have to find the probability that I grab an orange and multiply that by the probability of an apple after an orange is taken out. So the probability of getting an orange, now all the fruit is back, we reset. So we still have 16 pieces now. The probability that I get an orange is 4 out of 16. And if I take an orange out, there are now only 15 pieces of fruit left. So the probability of getting an apple after an orange is removed is 5 out of the remaining 15 pieces of fruit because there's now 5 apples. So I take 4/16 times 5/15, and that is 1/12 as well, which is 8 1/3%. So you're just as likely to get 2 apples as you are to get an apple or an orange than an apple. Interesting. And then lastly, what's the probability that we both grab bananas? So again, I have to find the probability that I grab a banana and multiply that by my friend getting another banana after I get one. So the probability that I get a banana is 7 out of 16. And then the probability that my friend gets a banana after I take one out is 6, because there's only 6 bananas left, out of 15 remaining pieces of fruit. So I take 7/16 times 6/15, and that gives me, sorry about that. My pen has a mind of its own right now. Times 6/15 is 7/40 or 17.5% chance. So we can see we're more likely to get 2 bananas than we are the other 2 combinations of fruit. So there were 3 examples of dependent events. You can see that second probability changes after the first event occurs. Let's take a look at this scenario. Cards labeled 5, 6, 7, 8, and 9 are in a stack. A card is drawn and not replaced. It's not put back. Then a second card is drawn at random. What is the probability of drawing 2 even numbers? So are these events, the first card and the second card, are these independent events or are these dependent events? Well, the second card I draw depends on what the first one is, because the first one doesn't get replaced. So these are dependent events. So to find the probability that I get two evens, I'm going to find the probability that the first card is even, and then I have multiplied that by getting an even again after I draw an even the first time. So the probability that I get an even card, there are two even numbers. There are 1, 2, 3, 4, 5 cards, and there are two evens. So the probability of drawing an even card is 2/5. Now what's the probability that I draw an even card again after I draw a card out? So let's say I draw an even card out. Now there's only one even card left out of the remaining 4 cards. So my probability is 2/5 times 1/4, which is 1/10, or a 10% chance. There's only a 10% chance that I will draw both of the even cards out when I draw 2 cards at random. So again, those dependent events really affect that second probability. Last one, a carnival game uses a spinner with 8 equal sections. To win the grand prize, the spinner must land on the section with the star 2 times. What is the probability of winning the grand prize? So here I need to spin a star twice. So are these events independent or dependent? Does the second spin depend on what I get the first time? It doesn't. It's not going to change my outcome. I'm still just as likely to get any of the outcomes no matter what I spin the first time. So these are examples of independent events. So now I just need to multiply the probabilities of the two events together. So the probability that I get a star times the probability that I get a star. So the probability that I get a star, there's only one star on the 8 sections. So the probability I get a star is 1/8. And then the probability that I get another star after that is still 1/8. So 1/8 times 1/8 is 1 out of 64, 1/64th, which is about 1.6% chance. Not a very good chance that I'm going to win this jackpot. So compound events can be either independent or dependent, and their probabilities are calculated differently depending on what type of events they are.